Namaskara. I am P.R. Happyoli from KLS Cocktails of Technology, Belgavi. We are in the learning process of third semester engineering mathematics, that is 18 Math 31. And I am dealing with third module, Fourier transforms and Z transforms. Dear children, we have come to the 11th lecture of this third module, and we have come to almost the last part of Z transforms also. So today, let me write. This will be the uh, hope you are ready with your pen and paper. This will be the 11th session or lecture of third third module 18 Mat 31. So here we start. Today is our very important topic. It is whatever we have learned. It's inverse. That is, it's reverse way. We are learning inverse Z transformations. The last lecture, in the last part of the lecture, I just told that we'll be learning inverse Z transformations. So quickly, we shall recap some of the inverse Z transformations. So we know that Z transformation of A raised to n, Z transformation of A raised to n is Z by Z minus A. So now we have to for reverse. So far we were going from n to z, that is Z transformation. Now we are going reverse, that is inverse Z transformation. So given, so Z transformation of A raised to n was Z by Z minus A. Z inverse of this is this. So we shall have some a list of formulae useful today. List of formulae useful today. So let me remind you that, for example, Z inverse of Z by Z minus 2, 2 raised to n. We used to write its reverse. That is a Z transformation of 2 raised to n is Z by Z minus 2. Let us get used to the reverse process. It will take little time. Z inverse of Z by Z minus 6. So it is 6 raised to n. Z inverse of Z by Z minus 1. 1 raised to n or 1. Z inverse of Z by Z plus 3. So this becomes, instead of plus 3 raised to n, this becomes minus 3 raised to n, and so on and so forth. Z inverse of Z by Z plus 1 is something raised to n, minus of this, minus of 1 raised to n. Along with this, we had some more list of formulae, which was, we know that Z transformation of n I'm writing reverse. Z transformation of n was Z by Z minus 1 whole square from here to here. Now we want to write inverse Z transformation of this is, similarly I'll write Z inverse of Z square plus Z upon Z minus 1 whole cube. Whatever is there, one less than that, but in this pattern it should be in this pattern n square. So we had used some damping rules also. I'll write in the side of that. And Z inverse of Z cube plus 4Z square plus Z divided by Z minus 1 raised to 4 n cube, and so on and so forth. We had used damping rule also. If I divide by a here, this will be multiplication by a here. That is Z inverse of z by a whole divided by z by a minus 1 whole square, and if you simplify this, az comes here, which is z inverse of az upon z minus a whole square. So because of division here, everywhere z by a, everywhere z by a, here it becomes multiplication by a raised to n. Similarly, today we are going to use the next one which I am writing. If at all I am going to divide here by z by a, z by a, z by a, how it looks like this: z by a whole square plus z by a whole divided by z minus z by a minus 1. And if you take LCM and a cube transfer here, so it looks like this now: z inverse of az square plus a square z. A comes here in the denominator, simplified. A comes here, z minus a whole cube. And because of this process of damping, instead of n square, you will get a raised to n square. A raised to n square. So dear children, using a equal to 2, suppose, can you tell me z inverse of 2z square plus 2 square z whole divided by z minus 2 whole cube? Today I am going to use this in one of the examples. So instead of a, there is 2 here, which is 2 raised to n square. So here we are almost ready for first example, but in the beginning, so let us in the beginning I'll consider there are 2 to 3 types of examples in the Z transformation. So what we are going to do is, from Z domain to n domain, that is Z inverse, we are finding now onwards. So for first example, the first category in the examples, first category of examples, find the inverse Z transformation using power series method. One more method is partial fraction method. The first example is, we are asked to find if u of z equal to log of z by 1 plus z or z plus 1. So what is the corresponding n function for this? For this, what we do is, the same thing can be written as log of, if I divide by z here and here to numerator and denominator, so how it looks like: z upon z plus 1. If I divide, here also you divide by z, and here also you divide by z. Now how it looks? Numerator becomes log of 1 and denominator becomes 1 plus 1 by z. So using laws of logarithms, log of a by b, it is log of 1 minus log of the denominator, and it is evident that log 1 is 0. So now 0 minus this, let us keep minus side outside, so this becomes this is 0. So let us keep minus sign outside and use the logarithm of Maclaurin series of logarithms, which is alternatively positive negative sides. Okay, alternatively positive negative sides, 1 by z upon 1 minus 1 by z whole square upon 2 plus 1 by 3 1 by z whole cube upon 1 by 3 minus 1 by z raised to 4 upon 4 and so on. Now if I keep a pattern of this, what happens if you take minus sign inside? Minus 1 upon z upon 1 plus 1 upon z whole square upon 2 minus 1 by 3 1 by z whole cube plus and so on. So can you write the same thing as minus 1 by 1 z raised to minus 1 plus 1 by 2 z raised to minus 2 minus 1 by 3 z raised to minus 3 plus 1 by 4 z raised to minus 4. So if you include 0 also here, so this is our u of z. By we can write therefore, taking z inverse on both sides, the pattern you have to recognize. This becomes u1, this becomes u2. So u1, u2, u3. So 1 by 1, 1 by 2, 1 by 3, alternatively positive negative, is a n function which is 0 for u0 and it is minus 1 raised to n upon n for n greater than or equal to 1. That is, if I put n equal to 1, I will get first one. If I put n equal to 2, I will get second one and so on. So corresponding to given function z inverse of log of z by z plus 1, its corresponding n function inverse z transform is its un, where un is equal to 0 or minus 1 raised to n upon n, according as first term n equal to 0, that is u0. From u1, u2, u3 onwards, it is this n function is the answer. So now by division process sometimes, which is little lengthier, let us understand that. Second one, if u of z equal to z by z square minus 3z, dear children, please see this very carefully. Z square minus 3z plus 2, find inverse z transformation. Now what we have to do is consider this first as it is. You should write consider the given function. So second one is, what you do is, by the highest power you divide here z upon, and here also you take common. I can write 1 minute. Z upon, here if I take z square common, how it looks like? 1 minus 3 by z plus 2 by z square. I'll tell you why I'm doing this. And now this looks like 1 by z. So if at all I take, suppose there may be some constants also here. It may not be always 1 by z. Suppose if I take 10z here. So this will be, let me take this example only, 10z here. So what it becomes now? If you simplify this part, it becomes 10 by z into 1 minus 3 times z raised to minus 1 plus 2 times z raised to minus 2. Now this will be written in terms of negative power of z always. Hence I can write in the numerator z raised to minus 1, denominator 1 minus 3 times z raised to minus 1 plus 2 times z raised to minus 2. Now with the usual process of division, which I will consider in the right hand side here only. See what I am going to do. With the usual process of division means what? I have to divide numerator by denominator. So suppose if I write here 10 times z raised to minus 1, this has to be divided by denominator, which is 1 minus 3 times z raised to minus 1 plus 2 times z raised to minus 2. Now looking to this, always you have to look to this 1 and find this, whatever is the first term, you multiply here and keep here. So that if I write 10 times z raised to minus 1, multiply here to every term and keep it here, how it looks like this now. This is z raised to minus 2 as it is. So if I multiply here, it becomes first term as it is 10 times z raised to minus 1. Second term, what you have to do? Multiply 10 and minus 3, minus 30 times. What are the power of z now? Z raised to minus 1 into z raised to minus 1, which becomes z raised to minus 2. The next term, if you multiply 10 into 2, 20. Okay, 20 times z raised to minus 3. Hope this is minus 2 is very, very clear to you. Wait, let me make it little clear to you. So let me rewrite that just for the sake of clarity. Okay, very nice. Very nice. Now, for the sake of clarity, I will rewrite this part. Okay, what we were considering, coming back to our usual method, we are dividing 10 times z raised to minus 1 by denominator 1 minus 3 times z raised to minus 1 plus 2 times z raised to minus 2. So now you look at the first term. So to make it this, you have to multiply by 1, you have to make 10 times z raised to minus 1. Multiply by z raised to minus 1 to all these terms. So multiply by 10 raised to z raised to minus 1 to all these terms and keep it here. So what happens if you keep it there? As if the usual division of polynomials, first term 10 times z raised to minus 1. Okay, minus second term, you multiply here and here 30 times z raised to minus 2. Third term 10 into 2, 20, z raised to minus 1, z raised to minus 2. If you multiply z raised to minus 3 plus 20 times z raised to minus 3. Now in the usual way, when you subtract, these two terms will get cancelled. When you subtract, so these two terms will get cancelled. So now when you subtract, minus becomes plus 30 z raised to minus 1. This becomes minus 20 z raised to minus 3. Continue the process of division. Now you look at first term. You have to look at the first term here, which is again 1. You have to multiply by plus 30 times z raised to minus 2. To all the three terms here, so what I am going to get? 30 times z raised to minus 1 minus 90 times z raised to minus 2 . So when you are doing this becomes minus 2 here. So you are multiplying by minus 2, 30 times z raised to minus 2. Now it is correct. So when you multiply these two, you will get 90 times z raised to minus 3, z raised to minus 3. And when you multiply here, you will get plus 60 times z raised to minus 4. Once again, you see 30 times z raised to minus 2. And first terms are getting cancelled. And this becomes plus, this becomes minus. When you subtract, you are going to get 70 times z raised to minus 3 and minus 60 times z raised to minus 4 when you subtract in a usual fashion. Now again look at the first term and look at 1 and you multiply 70 times z raised to minus 3 to all these terms and keep it here. So what we are going to get is 70 times z raised to minus 3 minus 210 times z raised to minus 4 plus 140 times z raised to 140 times z raised to minus 5. Again when you subtract what we are left with is first terms are getting cancelled. So 60 and plus 210, it becomes 150 times z raised to minus 4 minus 140 times z raised to minus 5. Now if at all again I have to multiply, I have to multiply here by first term which is so this becomes unending process, 150 times z raised to minus 4. So some results will get back, but this becomes infinite. Hence this part whatever is there, the answer, but infinite we are going to get infinite series. So u of z is therefore equal to see this part I am going to write this part 10, 30, 70. So that part is 10 times z raised to minus 1. Second term 30 times z raised to minus 2 plus third time, can you see that 70 times z raised to minus 3. Fourth term, if you complete that, you will get 150 times z raised to minus 4. But this is unending, that's why we write infinite process. Can you take 10 common here, which is equal to 10 into bracket 1 by z plus 3 by z square plus 7 by z cube plus 15 by z raised to 4 and so on. Now to get a pattern of this, because the coefficients of z becomes u1, u2, u3, u4 along with 10. So 10 times this is 2 minus 1. This is 2 square minus 1. This is 8 minus 1. 2 cube minus 1. That is, this becomes our u1, this becomes our u2, this becomes our u3 is 2 cube. Then next will be u4. u4 will be 2 raised to 4. 2 raised to 4 means 16 minus 1. So in general what happens is 2 raised to n minus 1 upon z raised to n. So this pattern of 2 raised to n minus 1 itself becomes un, of course multiplied by 10. So now if I take inverse Z transform using our power series method, we write this becomes our un, which is equal to 10 times 2 raised to n minus 1 is our answer. So whenever we are dividing, this is a usual fashion of division. Suppose if I do go to the second example of division using the division process, okay, if u of z equal to z by z minus 1 into z minus 0.5, find inverse z transform. Now if I can simplify denominator multiplying this, 1 z square term I will get. Okay, when you simplify minus 1.5 times z, you will get minus into minus plus 0.5. In a similar fashion, like in the last time what you did, if you take 1 by z square outside, you are going to end up with z raised to minus 1 whole divided by 1 minus 1.5 divided by z means 1.5 z raised to minus 1. This divided by z square, which is plus 0.5 z raised to minus 2. So if you take z square common, z by z square common, this starts looking like this: 1 minus 1.5 divided by z. Instead of that, I am writing z raised to minus 1 here, plus 0.5 divided by z square, which is rearranged like this. Now if you apply the division process of the same like last time, u of z, you are going to get something like z raised to minus 1 plus 1.5. This I am giving you. You have to find this answer, z raised to minus 2. Apply the similar method I told in the previous, plus 1.7.75 times z raised to minus 3 and so on. Okay. If I now take this, becomes 1 becomes u1, 1.5 becomes u2, 1.575 becomes u3. That means u0 is 0. So z inverse of this function, sometimes what happens is you will get un in terms of discrete values, where un is u0, u1, u2, u3 and so on, whereas this u0, u1, u2 by observation u0 is not there, 0, coefficient of z raised to minus 1 is 1, next is 1.5, next is 1.75. Sometimes this becomes the answer, where directly you cannot find un in terms of n. Sometimes there are some other easy methods which I would like to show you in example number 3. Suppose u of z is equal to z by z minus 2 whole square. U of z equal to z by z minus 2 whole square. Now if I take z common, in this case z by denominator becomes z square into 1 minus 2 by z whole square. So this, if I simplify, it becomes 1 upon z into bracket 1 minus 2 by z raised to minus 2. I will recall one formula here, 1 minus x raised to minus 2. If both are negative, all the terms here you will get positive. 1 plus 2x plus 3x square plus 4x cube and so on. Just to make our memory fresh, sometimes we use this formula: 1 minus x raised to 1 plus x raised to minus 1, 1 minus x raised to minus 1, both are same, here both negative and here one positive and negative, and 1 plus x raised to minus 2. Suppose if I write this, you will get alternatively positive negative 1 minus x plus x square minus x cube plus x raised to minus 4, alternatively plus 1 minus 1 plus 1 minus 1. Second one is same, but all the terms positive you will get 1 plus x square plus x cube and so on. Third one, you will get alternatively positive negative. If one of them is plus, one of them is minus, alternatively positive negative. So 1, 2, 3, 4 will be the coefficients. Alternatively negative positive now, which is 1 minus 2x plus 3x square minus 4x cube and so on. This also you can remember. At present we are going to use this. So our x is now 2 by z. This is our x. Now if I substitute here, we are going to end up with u of z equal to 1 by z into bracket 1 plus 2 times, okay, 2 times x. Can you write that? 1 plus 2 times 1 plus x 2 by z plus 3 by z square plus 4 by z cube and so on. Okay. Here a small correction I'd like to do. Instead of minus 2, let us take minus 1 here, 1, and here 1. So 1 by z I am writing x equal to 1 by z. So we are going to have 1 plus 2x plus 3x square plus 4x cube and so on. If I multiply by 1 by z inside, I am going to have 1 by z, 1 into 1 by z plus 2 into 1 by z square plus 3 into 1 by z cube and so on. First term, second term, third term, nth term will be n into 1 by z raised to n. Hence, you can see that if I take inverse z transform, the first term is 0 and in the remaining term 1, 2, 3, 4 becomes n. This is first term is for n equal to 0, remaining for n is greater than or equal to 1. This becomes our inverse z transformations. So these are the examples where you are going to use what is known as either division process or some adjustments like this. But sometimes will be, if at all division process power series is not asked, sometimes partial fraction method is very useful. Next example, maybe example number 4, I am going to deal with. Suppose find, these are also very important examples. Find z transform, inverse z transform of u of z equal to 2z square plus 3z divided by z plus 2z minus 4. Now carefully you see, first of all I'll consider this. First step you can always write like this. Second step is u of z upon z equal to, if you take one z common and transfer, if you take one z common here and transfer to the left hand side, this becomes 2z plus 3 whole divided by 2z plus 3 whole divided by z plus 2 z minus 4. Now all of us know that the partial fraction of this is a upon first factor. Suppose I can take z plus 2 and b upon second factor, I can take z minus 4. Here I'll teach you a very simple method of finding z. To find a, what you have to do is, please see carefully. To find a, what you have to do is, see carefully. This part you put z equal to minus 2. This part you put z equal to minus 2 to find a. So 2 into minus 2 minus 4 plus 3 divided by minus 2 minus 4 minus 6. Minus 2 minus 4 minus 6. So this becomes our a divided by z plus 2 as it is. Very similarly, if at all you want to find b part, you neglect this z minus 4 here and put z equal to 4 in the remaining part. Z equal to 4. If you put z equal to 4, it is 2 into 4, 8 plus 3, 11 plus 11 upon here you put z equal to 4, 4 plus 2, 6. So this is our b, z minus 4. So we are ready with the answer of partial fractions, which is, if I transfer u of z also that side, first of all, this is minus 1 upon minus 6 becomes 1 upon 6. Z this side becomes z by z plus 2 plus 11 by 6 as it is. So if you transfer z this side, it becomes z by z minus 4. Now this is in a very standard format. Z by z minus a, its inverse transformation is a raised to n. So here it is 4, it becomes 4 raised to n. First term is minus 2 raised to n. Corresponding n function, therefore z inverse of u of z, which gives us n function, is 1 by 6 times z inverse of z by z plus 2 plus 11 by 6 times z inverse of z by z minus 4. So final answer un is 1 by 6 times, this becomes plus 2 becomes minus of 2 raised to n plus 11 by 6 into 4 raised to n, corresponding n function. Dear students, let me teach the same thing instead of repeating in the next example. Maybe example number 5. Maybe example number 5. So now in the example number 5, suppose u of z equal to 8z square upon 2z minus 1 into 4z minus 1. Now first of all, better you should take this 2 outside, 4 outside, and both of them are z square highest coefficients. 1 z you transfer this side. First of all, I take u of z by z. So 1 z remains here. Here I am taking 2 common in the first bracket. I get z minus half. The second bracket, I'll take 4 common. I'll get z minus 1 by 4. You can very easily observe that. This 8 is getting cancelled. 8 is getting cancelled with the 2 into 4. So shall we write u of z by z equal to z upon first factor into z minus second factor, z minus 1 by 4. So this is naturally a by first factor plus b by second factor. Now to find a and b, whatever I told in the previous example, the same method let me apply here. So what children we are finding here? First you put z equal to half in the remaining part. You leave this z minus half bracket in the remaining part, that is here you leave this part. In the remaining part here and here you put z equal to half. So what we are going to get, let us see. If you put z equal to half, in the first half upon, for A I am writing this z minus half. Similarly, we shall find B also. First of all, I will concentrate on A. To find A, leave this part z minus half here and half here. Half minus 1 by 4, it is 1 by 4. Okay, half minus 1 by 4, 1 by 4. Similarly here, to find B, you will leave this z minus 1 by 4, and in the remaining part you put z equal to 1 by 4. 1 by 4, 1 by 4. So 1 by 4 divided by 1 by 4 minus half is minus 1 by 4. Once again, to find this A, put z equal to half in the remaining part except z equal to, except the first bracket. Half here, half here. To find B part, put z equal to 1 by 4, leave this bracket and put 1 by 4, 1 by 4. So what we are going to end up is u of z by z equal to, first one is 2 upon z minus half. Second one is minus 1 upon z minus 1 by 4. Now if I transfer this z in the denominator of left hand side, to get u of z equal to 2 times z by z minus A type minus z by z minus 1 by 4. And now if I take the inverse z transformation, z inverse everywhere, if I take inverse z transformation, z by z minus half, if I take inverse transformation everywhere, because z inverse is also linear, every term will get z inverse. Right hand side, after taking z inverse, naturally we are going to have some n function. So let us see what is that n function. Can you help me to write that n function? So corresponding to this, we are going to get some un function which is equal to okay, 2 times, because of this half we will get this raised to n, because of this half we will get half raised to n here, minus of, because of 1 by 4 we are going to get 1 by 4 raised to n. So now we are using partial fractions to find inverse z transformation, that is given. See what I did in the previous example. This was given to us. So first I transferred one of the z to the left hand side, created u of z by z so that it becomes a proper fraction also. Then I made the coefficients of this as z, which is getting cancelled with 8. And because of the linear factors a upon first factor, b upon second factor, then to find a, I substituted z equal to half in the remaining parts, which is not z minus half, half here and half here, which I got 2 for that a, and z equal to 1 by 4, which I substituted in this part, so that I'll get minus 1. So once I get in the pattern, this is the right pattern we got. So z by z minus a pattern, which is half raised to n and 1 by 4 raised to n. If you are ready, shall we do the next example? Example number, you start putting that next example number. So once we are used to the, if they are linear factors, I think there should not be any problem. If they are not linear, then we have to work out it a little bit. For not linear also I will show you, but one more for linear. Are you ready? If u of z equal to 220 z square plus z whole divided by 2 and 3. Now let this be equal to So again A and B you have to use. Let u of z upon z first of all, because both are z square and z square highest coefficients. To make it a proper fraction, I'll reduce it by 20z plus 1 whole divided by, are you with me? Whole divided by z minus 2, z minus 3. Now we can write, now we can write for this. So new teaching pads sometimes behave very strange. A by z minus 2 plus b by z minus 3. And this part let us use to find u of z upon z. Now let me show you again how we are finding the first A part. To find A part, leave z minus 2 and in the remaining you put z equal to 2 here. 20 into 2, 40 plus 1, 41. U of z upon z therefore looks like this. For A, put 2 here and 2 here. 20 into 2, 40 plus 1, 41. Divide by denominator 2 minus 3 minus 1 whole divided by z minus 2. So in the numerator what I have written is A plus B is put z minus 3 in the remaining except z minus 3 factor. Don't put here. So that 20 into 3 is 60 plus 1 61 upon 3 minus 2 1 whole divided by z minus 3. Now almost it is see such type of examples are many times asked in the examination. Almost we are ready for the un function if you are with me. So what we did in the similar fashion, how we found A and B here, in a similar way we found A and B here also. Let us see how do you find un function. Can you find un function here? Take I am giving you some time. Take z inverse on both sides. I'll wait for you. Along with me, you write your un function. Let me see what you can write. Corresponding un function. Have you written? Yes, any answers you can, if at all you can tell. This implies that if I take z inverse corresponding un minus 41 raised to 2 raised to n plus 61 raised to 3 raised to n, taking z inverse every side and taking z this side, I am writing the answer directly for you. Or you can reverse this as un equal to 61 times 3 raised to n and minus 41 times 2 raised to n, taking the inverse. So very similarly we shall do some more examples in the coming session, but I would like to give you some one of the homework of the same category which you do it using this inverse transformation. The last part of the inverse Z transformation we are going to have as difference solving of differential equations. So are you ready for some of the examples of the similar case? So then please note down for my sake. Very similar for you. If at all u of z is 3z square plus 2z whole divided by 5z minus 1 and 5z plus 2, show that corresponding un equal to, I will give you the answer, 1 by 75 times 13 into 1 by 5 raised to n plus or minus, you can write minus 4 by 3 minus 4 by 3 minus 2 by 5 raised to n. Try to do this homework. I'll continue with the example of inverse Z transform. Next example, find inverse Z transform of Z cube minus 20Z whole divided by Z minus 2 whole cube. So you should see what is the difference between this example and the previous example. In the solution part, what I'll do is, let the given function be some function of z. Usually u of z we take z raised to 3 minus 20z upon z minus 2 raised to 3 into z minus 4. The usual pattern is we take u of z upon z here. So the numerator in the right hand side becomes z square minus 20 whole divided by z minus 2 whole cube into z minus 4. Now there is one way of writing it, and there are actually two ways. One way I am showing you. For the first z minus 2 whole cube, I write a plus bz plus cz square whole divided by z minus 2 whole cube. There is one more way which we will discuss for the next example. Plus for the second z minus 4, z minus 4. Now we create a equation to find ABCD. So but note down that we use only this part to find ABCD first. So now if you multiply by the denominator, z cube minus 20 equal to a plus bz plus cz square, this into z minus 4. Okay, are you following it? Yeah. And second one, d into z minus 2 whole cube. This acts as an identity. Let us again mark it as some equation 1, 2, 3 or some equation. Let me mark it as suppose star. Now to find ABCD, I can choose z equal to 0, 2, 3 or 2 and 4 here, or compare the coefficients. In the first case, if I put z equal to 4, this whole thing becomes 0 and I'll get d. That observation, if you have put z equal to 4 in that equation star. So this is z square minus 20. If I put z equal to 4, naturally 4 square minus 20. This has become 0 and this is d into 4 minus 2 whole cube. This implies 16 minus 20 minus 4 equal to here minus 2 cube, which is minus plus 2 cube, which is plus 8 times d. And this naturally implies d is minus 4 by 8 or d equal to minus 1 by 2. Let us note down this first. First value is d equal to minus 1 by 2. You got d equal to minus 1 by 2 you got. Now similarly, if I start finding next one, suppose if I put some value, say if I put z equal to 0, in the same equation star, left hand side becomes minus 20, right hand side is a into minus 4 and plus d into minus 2 whole cube. Everywhere minus sign if I cancel, 20 equal to 4a, okay, plus 8d. But we know the value of d as minus half. If I substitute that, 20 equal to 4a plus 8 into minus half. So this minus 4, if I transfer this side, 24 equal to 4a or a equal to 6 can be noted. So we found the value of d as well as a. To find the next value, what I do is, let me select some coefficient. Suppose if I take the coefficient of z cube in star, if I compare left hand side of star, there is no coefficient z cube here. No coefficient z cube means 0. Right hand side, z into cz square, cz cube. So c you will get, and this z minus 2 whole cube, z cube into d plus d. So already we know d. This implies that c equal to minus d means minus of d means minus of minus plus half. So we note down that c value is plus half. C value is plus half. To find d value, what I'll do is I'll substitute z equal to some value. We can substitute z equal to 1 or minus 1 are the handy values. When I substitute z equal to 1 minus 20 minus 19 equal to a plus b plus c into minus 3 plus minus 1 d into minus 1. Everywhere minus signs are there. You can first of all cancel these minus signs. 19 equal to, since we are finding b, let us separate b. So minus values are cancelled. Looking to that, taking that into consideration, 3 times a plus c minus of minus plus d it has become now, and b part is 3b. This part we want to find. If I substitute a, c, d values, so 19 equal to a is 6, c is plus half, d is minus half, plus 3b as it is. Now minus half, if I transfer to the left hand side, 19 plus half becomes 3 times 13 by 2 plus 3b as it is. What you observe? Left hand side also 2 into 19, 38 plus 1, 39 by 2. Right hand side also it is 39 by 2 plus 3b. So this is possible only if b is 0. So we found that all a, b, c, d values we found. Shall we note down once again? A equal to 6, b equal to 0, c equal to plus half, d equal to minus half. All these things put in 1. This 1 I have not so far shown. This is our 1. So a equal to 6, b equal to 0, c equal to plus half, d equal to minus half. If I substitute u of z by z, I am going to get. U of z by z I am going to get. So allow me to write that u of z by z. Therefore 6 plus 0 c, okay, a plus bz plus cz square half z square whole divided by z minus 2 whole cube. D is minus half into 1 upon z minus 4. First you note down this part what you wrote. Now before we transfer z this side, let us simplify this. 12 plus z square half I'll take outside, z minus 2 whole cube. Let us take half completely outside. Now we simplify in a different fashion. I'll make a perfect square in z minus 2 whole cube whole square. Z square, I require minus 4z, which I'll compensate after writing plus 4z, plus I require 8. So what is remaining? Minus 4z should be plus 4z, and 8 plus 4 is 12 compensated. Whole divided by z minus 2 whole cube, and second term as it is. That's why I told this example is little different from previous example. Little practice. So first term bracket has become z minus 2 whole square. Second one you can write 2 common and write it as 2z plus 2. So you took the value of 2. Either you can take common or keep as it is. So this small change, 4 here and 8 here, 2z plus 4. Now divide by z minus 2 whole cube. Note down, we require z minus 2 whole square is 4 here. So 4 plus 8, 12 remained as it is. So this 4 has come here, minus 1 upon z minus 4 as it is. Now separate first term divided by z minus 2 whole cube, second term divided by z minus 4 whole cube, u of z by z. Therefore now looks like this: 1 upon z minus 2 whole cube. We are almost near now inverse z transform, plus 2 times 2z plus 2 square upon z minus 2. This is 1 upon z minus 2 raised to 1, z minus 2 whole cube, minus 1 upon z minus 4. Now if you observe that u of z therefore finally looks like this: half of z by z minus 2 is the half of z by z minus 2, the first term. Second term, if you multiply and divide this half and 2, you will get 1. So this purely looks like az plus a square divided by z minus a whole cube. This next one is half of 1 upon z minus 4. So totally now it is ready to take inverse z transform. Z inverse of each term, taking inverse z transform, you can write down this, taking inverse z transform. So half of z inverse of first term, z by z minus 2, plus z inverse of 2z plus 2 square upon z minus 2 whole cube, minus 1 by 2 minus 1 by 2 z by z minus 4. So what happened? So when you multiply this z this side, z has come here, 2z square plus 2 square z, 2z square plus 2 square z. Now they are in the perfect form. This side un half, this becomes 2 raised to n, plus, if this would have been 1, this would have been 2 raised to n or n square. To this n square you have to multiply this part, 2 raised to n, and remains is minus 1 by 2 4 raised to n. This part I'll remind how we got this part. What is z of n square? Is z square plus z whole divided by z minus 1 whole square. Now if I multiply by 2 raised to n this side, so we had learnt damping rule that everywhere you have to divide. This is raised to 3. Z minus 2 whole square plus z by 2 whole divided by z by 2 minus 1. Multiplied, divided. If you simplify this, exactly you are going to get 2z square. Okay, this becomes raised to 3. If you simplify this, you are going to get this part. This is same thing as this part. That is inverse of this is 2 raised to n square. So noting this, we will move ahead for the next example. Some similar example. Find inverse z transform of u of z equal to 2 times z into bracket z square minus 5z plus 6.5. Sometimes you may get rarely z minus 2 into z minus 3 whole square. So first of all we write consider this part. Consider this part. Then we write u of z by z, usual customary. This becomes 2 times z square minus 5z plus 6.5 whole divided by z minus 2, z minus 3 whole square. Of course we can write like the last time, but I would like to write, let this be partial fractions like a upon first factor, b upon z minus 3, and for repeated factor c upon z minus 3 whole square. Now using only this part, we shall find what is u of z by z. So for that you have to multiply by the denominator of this left hand side, 2 times z square minus 5z plus 6.5 equal to, carefully, a into z minus 3 whole square plus b into z minus 3 z minus 2 plus c into z minus 2. So this becomes star. Taking z equal to you are going to get 2, you will get a value. So I'll just give the values of a, b, c here. A equal to 1, very easily you can find. Taking z equal to 3, you will get c value. This is a c value. C is also 1. And if you put z equal to 0, so z equal to 2 gives you a equal to 1, because we have done like this. Taking z equal to 0, you can create equations. Okay, like you will get 13. Z equal to 0 means this part 0, this part 0, 2 into 6.5, 13. Very easily you can see 13 equal to some equation is ABC, 9a. You can very easily see this, 9a. Here 0 is 0 plus 6b minus 2c. Except b, we know all this together and ABC together value will end up in b value also as 1. So when you write this ABC value and simplify, u of z, you are going to get z by z minus 2 plus z by z minus 3 plus z by z minus 3 whole square. Perfect. They are in the perfect shape of taking inverse z transform. Z inverse of left hand side equal to z inverse of first term plus z inverse of second term plus z inverse of third term. So z inverse of u of z is un. This becomes 2 raised to n. This becomes 3 raised to n. And here, because remainings are same, here what happens is, since it is not z minus 1, since it is z minus 3, you require to multiply 1 3z here and 1 3 here, because z by z minus 1 whole square, its inverse is n. But if at all I want here, suppose if I multiply by 3 raised to n into n, this becomes z inverse of 3z upon z minus 3 whole square using the damping rule. So 3z upon z minus 3 whole square is here because we adjusted. To get this 3z, I have to multiply by 3 and 3, and this remaining part, this becomes our 3 raised to n into n. So this is 1 by 3 times, you should note down that, 3 raised to n into n. Okay, so we learnt inverse z transforms. All this knowledge will be in the next class. We'll be using it in the solving difference equations. See you. Bye.